Hi everybody. Phil says I'm going to tell you about Flow, which is our system for controlling the design and engineering stage of complex projects, and which in recent times we've seen enable some new behaviours within some of the project teams using it. So I'll touch on that as well. Let's just start by looking at the challenge. Here are UK industry charts for the predictability of delivery to time of both design and construction over the years. There's obviously a relationship between design and construction. If we're not delivering to time in design, we're unlikely to in construction, or there'll certainly be an impact there. There's also a relationship between between time and cost. If we're not delivering to time, we're unlikely to be delivering to cost. And in fact, the cost charts, which I don't have on screen, they follow similar sort of profile. So as you can see, the performance isn't brilliant, and probably just as worryingly, it hasn't changed very much over time. And one thing we know is that this is not particular to the UK. The figures from overseas and indeed from other industries are similar. So let's look at a couple of the reasons why, two of the main reasons why design and engineering is such a challenge to keep control of. Firstly, the activities are driven by something which is intangible, and that is information flow. This is a little process model of activities and information flows. So unlike construction, where we can see materials, resources, contracts, in design and engineering, we're dealing with information, and it's very often intangible. That makes it very challenging. The other thing to note, the second main point, is that the process is iterative. And you can just see there on screen, I've highlighted 4 activities there that are within an iterative circuit. So this is not a linear process like building and construction. This is an iterative process. So let's just have a quick look at a couple of projects that I'm going to refer to. One of them is in the UK, in Birmingham. It is the tallest building in Birmingham, 212 Broad Street. It is a 481 apartment building, the tallest skyscraper in the city. The second is a 40,000 square foot industrial facility, waste, recycling and processing facility on the site of a US naval station. So they're both reasonably complex. They're different in nature, but both share that characteristic of being complex and involving civils work, structural work, architectural design, MEP design, and having input from the client, obviously from the contractor and from specialist contractors with some design input. So Flow is a system which integrates a number of techniques, and I'm going to talk to you about those and how we've implemented those techniques on those 2 projects and in some others. And later on, I'll give a quick insight into how the implementation of the method and of those techniques has impacted those or been borne out in those 2 particular projects. So the first method is process modeling. Flow makes use of process modeling or process mapping. And here on screen, you can see a process map, a relationship diagram, which is that rather funky looking spirograph style diagram that flags up where really key relationships are between activities, and a work breakdown structure and a relationship mapping, which you can see on the right hand side there. So we define the process in the form of these process models and process maps. Now, it's worth saying that whilst I'm here to talk about technology and how that's made a big difference, when we're doing this process mapping and process modeling, we find it's really important to engage the project team, because they're the ones that have got to own the process and commit to delivering the plan that results from it. So as well as the technology, we use some more traditional methods, such as post-it note and marker pens, with their input to define that process to then, as a result, get them to commit to the plan. Now, having defined the process, what we have is an ability to plan and an insight into the complexity. And because of that complexity and the iterative nature of the process, we use this second method, which is this matrix-based method called dependency structure matrix, or DSM, to really get an understanding. And I can't spend too much time on this. I could spend 30 minutes on this alone. So I'll just touch on this really quickly. And if you want to know more, you can let me know. What's happening here is that the cells within the matrix represent dependencies or information flows. As I've said, those dependencies are in the form of information flows between activities. And we sequence this matrix to maximize the availability of information and to minimize the number of assumptions that the team have to make as the result of missing information. And down that diagonal line that you see running across the screen, we have clusters of activities that are not just dependent, but interdependent. And that is where the iteration would traditionally exist within the design and engineering process. And there you go, that's back to that's the kind of cluster of activities that's represented as we saw on that earlier diagram. Now, when we come to plan these activities, these clusters, I'm referring to them as iterative. Now, what we don't want to do is plan a process that goes 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 3 iterations of 4 activities, because that's long-winded. That turns that into a long-winded process. What we want to plan is 1 and 2 and 3 and 4. Those 4 activities being undertaken concurrently through collaborative working between the parties involved. And we can do that because what we find is that, and we found on these projects, is that those clusters of activities represent areas that require close coordination, typically systems and components of the built assets that have physical interfaces. So, having streamlined the process, we can then put it into the form of a plan. And we have a scheduling capability within Flow, but we also interface into on these projects into Power Project and Primavera P6, which clients are using. And it's worth saying at this point that process modeling that I described a moment ago is a really crucial step in getting to this plan. If you just go straight to the plan, you invariably force yourself into planning a linear process, and you miss some of those interfaces and those interdependencies, because these planning systems are designed to model linear processes. So it's really important to do that process modeling as a precursor step. Now, when we've got the plan, we've got a route through the project. But what we really want to do is understand where the hold-ups and the blockages are going to be, a bit like a sat nav would be compared to a map. And that's what we do in the final stage of Flow, where we use the principles of the last planner method combined with issues and actions management. And what we do here is we take a short-term look ahead of activities that are due in the plan, and have all the team members report, and everybody's reporting continuously throughout the process, and I can see who's been reporting by the progress icons on the left-hand side. I can also see, as the manager of the project, where we've got activities started or finished at risk. In other words, the right information isn't yet available, but those activities are underway or finished. So that represents, as I say, that represents risks. And at its very simplest, you can see on the left-hand side of the screen there, there's a clue as to what we're asking people to report, and that is simply whether activities are started or finished, or in some cases not started. They probably should be if they're in the look ahead. So they're reporting that sort of progress, and then we're asking them to also report on the remaining time and the remaining effort. So it's pretty simple stuff, but bear in mind we're interested in keeping control of time, so we naturally be asking that type of question. We're not interested in percent complete, we're interested in remaining time, as I say, and remaining effort. And what we're also asking the team to do is to tell us where, if activities that should be completed or progressed aren't, to tell us what the reason is, and we demand that they record the reason for that, so we can understand what's causing the delay. And also what goes with the issue is any action that can be identified to overcome that issue. And if they can't identify an action at this point in time, we can do that later on in the design team meeting. And both of these projects did that kind of thing, and I'll touch on that in a minute or two. So we're collecting information about delays, and I'm just going to ask a quick question here, and there's going to be a poll pop up on your screen. In your experience, what's the most common root cause of delays in the design stage of projects? Client indecision or change, shortage or problem in design team results, quality of information produced by the design team, or contractor reviews, approvals, and appointment of subcontractors, or something else. So quickly respond to that. And while you do, I shall say that there is no right answer. We see projects that are very much suffering from client change, such as projects, where you've got fast-paced projects with demanding clients with tough requirements. We have projects in design and build type of arrangement where there are contractor issues. We don't often see the quality of the design information being the primary root cause. It often feels like it is, but normally the root cause is one of these other things. Can we get the results of that up on the screen? Okay, so we've got a lot of quality of information from the design team. That's interesting. And as I say, very often in our experience, that's not the root cause. It feels like it is, but it's often client change or contractor delays. Good to see that shortage of design team resources isn't getting a mention there. So I'm just quickly going to show you some of the outputs from our project. Here's the first one, 212 Broad Street. We've got our inputs at the top in terms of our process model, and at the bottom you can see the performance of the project team measured in terms of the erosion of remaining work on the left and the completion of activities on the right. This is really, really stellar performance, 97 and 94% stood out in September. Here's the second project, and remarkably, it's even better. An SPI and a CPI have essentially won. And this is on these two projects. There's two main reasons for this incredible performance, and I'll show you what performance typically looks like. Something more like that. The reason for the performance here is that we've got a really strong focus among the design team leader, and that's the contractor in the first project and the architect in the second, on delivery to time. And we've got a very strong commitment among the design team as well. And that's come about from the use of the system. So that's where the system is enabling this sort of behavior. The other thing that's happening is that the teams have been using Flow within their design team meetings to review the issues and problems that have been raised, and to identify the actions and work on closing out those actions. So by understanding the issues and the actions, who raised the issues, why the action needs to be undertaken, and what the timescale is for that action, we've seen a really positive impact on the behaviours of the team, and that's a direct result of having the system in place. So just to finish up, I'm going to go right back to the beginning. This is all about improving predictability, and what we've seen is a number of benefits in that area on these two projects, and indeed on some others. And what you get is savings in the design stage as a result of removal of wasteful process, measured in the thousands to the tens of thousands, and a knock-on effect into construction measured in the hundreds of thousands, and even beyond that into the millions in some cases, through this increase in an improvement in predictability. And I'm just going to finish up by saying that we are looking to further improve the predictability and certainty that the system brings through further integration of it with already used BIM and project collaboration systems. That's our next area of development. So that's me. Thanks very much for your time. My contact details are on screen. If you'd like to know any more, please drop me a note, and I believe we're going to deal with any questions after the next session.